Welcome to this explainer. I am so thrilled you're joining me today. You know, if you've ever just sat there, staring at a screen packed with endless rows and columns of raw, confusing numbers, and thought to yourself, there has got to be a better way to make sense of this, well, you are in exactly the right place. Today, we're diving into an incredibly powerful tool that literally transforms those intimidating spreadsheets into beautiful, meaningful charts. So, that brings us to the big central question for today's explainer. You've got this data set full of numbers, right? But how do you actually quickly turn all of that raw data into attractive and meaningful charts? It's a super common struggle. We all know that just staring at a spreadsheet doesn't reveal the story hidden inside the data. We have to see it to understand it. And that is exactly where Seaborn comes in. It's an absolute game changer for beginners and pros alike. Here's our roadmap for today's workshop. We'll hit 1, the concept, 2, the plot menu, 3, setup and first code, 4, adding complexity, and finally, 5, Matplotlib comparison. Let's get right into it.
Section 1, the concept.
Okay, let's dive into this. To use any tool effectively, you really have to understand what it fundamentally is. So what is Seaborn? Simply put, it's a Python data visualization library designed specifically for statistical graphics. But what does that actually mean in plain English? Basically, it provides a high-level interface. That means it needs very little code from you to create useful visualizations. You absolutely don't have to code every single line, access, and color from scratch. It does the hard work for you. I actually really love this analogy from our source material. Think of Seaborn as a smart chart-making toolbox. Imagine you've just hired an expert designer. You hand them your data set and tell them what relationships you want to see. You say, hey, show me the relationship between the price of a house and its size. And Seaborn just handles almost all of the visual formatting, the colors, the layouts, the whole shebang. It does the heavy lifting. So why do data scientists and analysts rely so heavily on this library? Well, primarily because it's just incredibly efficient at exploring relationships, trends, and those hidden patterns in your data. It completely understands distributions and categories, helping you spot weird outliers instantly. Plus, and this is a huge bonus, it works really closely with Pandas data frames, which you can just think of as Excel spreadsheets inside Python. And it builds seamlessly on top of another library called Matplotlib. It fits right into the tools you're probably already using. Moving right along to Section 2, the plot menu. You know, figuring out when to use which plot is basically half the battle in data science. Think of this as your visual menu. First up, the scatter plot. This is your absolute go-to for checking relationships between two numerical variables, like looking at a person's height versus their weight. Then we have the line plot, brilliant for showing trends and changes over an ordered variable, which is usually time. Think of tracking a stock's price over a year. And finally, the bar plot, which is just perfect for comparing categories, like total sales across different regions. Continuing our tour, here are 3 slightly more advanced but super powerful plots. The histogram, or distribution plot, helps you understand how numerical values are spread out, like seeing typical age ranges in a city. Then there's the box plot. This one is a lifesaver for comparing distributions and spotting those crazy outliers at a single glance. Lastly, the heat map. This uses visual intensity, colors getting darker or lighter, to show values across a matrix, which is basically just a grid of data. Seaborn makes spotting these complex patterns incredibly intuitive. All right, Section 3, setup and first code. So the crucial point now is putting this theory into practice. And the setup, it is incredibly simple, literally just 2 steps. Step 1, you pop open your terminal and type pip install Seaborn to download the library. Step 2, right inside your Python script, you type import Seaborn as SNS. Now, that SNS part, that's just the conventional shorthand everyone in the industry uses, so you don't have to type out the full word Seaborn every single time you want to make a chart. Okay, to give us a real, tangible example to play with, we need some data. The cool thing is Seaborn actually comes with several built-in sample data sets specifically for learning. So if we type tips equals sns.load_dataset tips, boom, we've instantly loaded a real-world dataset containing records of restaurant bills and the tips left by customers. Now we have something to visualize. And here we go, our very first piece of visualization code. Just look at how readable this is. Let's break it down. We call sns.scatterplot. We tell it our data is that tips dataset we just loaded. Then we literally just map the total_bill column to our x-axis and the tip column to our y-axis. That's it. Running that single line of code generates a beautiful scatterplot where every single dot represents one customer's bill. we can see exactly how the total bill relates to the tip amount. That brings us to section 4, adding complexity. Now, that base chart was great, but the real magic of Seaborn is how fast we can level it up. Let's say we want to know if people tip differently at lunch versus dinner. In Matplotlib, doing this would require a fair amount of code to separate the data and assign colors. But in Seaborn, we just introduced this magical hue parameter. By adding hue equals time to our code, Seaborn automatically maps that categorical variable into different visual groups. Suddenly, our scatterplot has blue dots for lunch and orange dots for dinner, fully equipped with a legend. It's effortless. Let's check out a quick distribution plot. Using sns.histplot, we're asking Seaborn to show us the spread of our data. We set x equals total_bill, and right away, we get a histogram showing where most of those bills actually land. Are they mostly $15, $30? Adding that KDE equals true parameter, which stands for kernel density estimate, just draws this really nice, smooth trendline curve right over the bars. It makes it so much easier to read. Next up, a beginner-friendly box plot example. Categorical plots like this are perfect for comparing groups side by side. So we set the x-axis to the day of the week and the y-axis to total_bill. In one line of code, Seaborn draws box plots for Thursday, Friday, Saturday, and Sunday. You can instantly spot which day has the highest median bill, check out how spread out the bills are on the weekends versus weekdays, and see any wild outlier bills. Now, I want to act as your guide here and save you some serious frustration. As you dive into this, you're going to hit a few common beginner mistakes. Things like simply typing the wrong column name, remember it has to match your dataset perfectly, or forgetting to actually install or import the library first. Another big one is picking an inappropriate plot type, like trying to use a line plot for categorical data. And finally, making sure you don't just blindly interpret a beautiful chart without actually understanding the underlying context of the data itself. Keep an eye out for those. Which leads us to our final section, number 5, Matplotlib comparison. Let's clear up a huge point of confusion for Python beginners. How exactly does Seaborn relate to its foundational library, Matplotlib? Well, Matplotlib gives you this crazy granular control over every single pixel of a plot. It is highly customizable. Seaborn, on the other hand, is that high-level interface focused on giving you attractive statistical graphics right out of the box. But because Seaborn is actually built on top of Matplotlib, they're basically best friends. You let Seaborn do the heavy lifting for the formatting, and you can always drop in Matplotlib code to tweak tiny details if you ever need to. So to wrap things up, Seaborn is an incredibly powerful toolbox that works directly with Pandas and Matplotlib to create amazing statistical visuals with basically zero effort. It takes all the pain out of formatting so you can actually focus on your insights. So I'll leave you with this question. Now that you understand how Seaborn works, what dataset are you going to explore visually first? Think about it and get ready to uncover some hidden patterns. Thanks so much for tuning in to this explainer.